Today's lesson is the 10.1 extension, and the learning target is to rationalize the denominator of a radical expression. Before we can begin to understand what that learning target means, let's do a quick review of what it means to simplify an expression. The very first time that you learned to simplify an expression was when you learned to reduce fractions. So when we reduce a fraction, we're putting it in its simplest form so that people can look at it. We're all looking at the same thing, and they don't have to think about what would it be simplified. We've already done that work for them. So we always want to reduce our fractions. When we are working with expressions, we also want to make sure that we don't have any perfect squares. So if I have the square root of 9, for example, in my expression, I want to simplify that to just 3. We also have done a little bit of work with the next two things where we've said that there can be no fractions in the radicand. So I don't want to have the square root of a fraction. And if that's the case, I'll want to simplify it. And you've done a little bit of this already that we'll see in just a minute in a warm-up. And then finally, the last thing is we want to have no radicals in the denominator. So we have done some work on simplifying expressions like these. And to show you that we've done some of that work, I'm going to give you a warm-up with types of problems that we did previously in our unit on exponential functions. So go ahead and pause the video and complete the work for these 4 warm-up problems, and then when you unpause, I will move on to the answers for them. Now that you've completed those warm-up problems, let's check your work. So for number 1, your answer should have simply been 6. For number 2, it should have been 3/4. Those two should have been so easy, but I put them on here to show you that when we simplify those expressions, you already know a lot of this. On number 3, we did this in our unit on exponential functions, and we came back and revisited it a couple weeks ago. So I know that this was a difficult skill, but I'm hoping that we're feeling pretty solid with it right now. That we're going to first start with the square root of 8 and simplify that so that it's 2 times the square root of 2. And then I always want to look to see if I can reduce. So I can reduce 6 over 2, and I can reduce 2 over 2. So 6 over 2 becomes 3, and 2 over 2 becomes 1. I don't have to write the 1. So my final answer on that one is 3 plus the square root of 2. And then on number 4, I'm going to take the square root of 25, which is 5. The square root of 50, I'm going to simplify that, so it's 5 times the square root of 2. And then I would reduce my fraction. 5 over 5 is 1 over 1, so my answer would be 1 over the square root of 2. So far, this is what you know how to do. This, however, is not fully simplified, because one of the things that we said is that we cannot have the radical in the denominator. So today what we're going to learn is what to do when I've got a radical in the denominator. So this lesson is going to be organized into easy, medium, and hard. And the easy problems are when I just have one term in my expression and I want to simplify it. So I'm going to start with a simple one where, for example, I have 1/3 under the radical symbol. So this initially violates the rule that I can't have a fraction in my radical. So I'm going to take care of that pretty easily by separating it into 2 parts. So I've got the square root of 1 over the square root of 3. And so I've taken care of that part of it. And now I have this radical in my denominator, which is in violation of the simplification rules. So I need to get rid of that. So one of the things that I know about any number that I'm taking the square root of is that if I square it, if I multiply it by itself, the square root symbol goes away. So I know that I can multiply this denominator by the square root of 3, and the square root of 3 times the square root of 3 is simply going to be 3. I also know, based on working with fractions for a long time, is that if I multiply the denominator by a certain number, that I also have to multiply the numerator by the same number in order for it to be an equivalent fraction. So I'm going to multiply my numerator also by that square root of 3. When I multiply two numbers that are under the radical symbol, I can just multiply 1 times 3. So this is going to be the square root of 3, and now I have fully simplified that expression. Notice that I no longer have the radical symbol in the denominator. On the next one, again, I'm going to split it into two parts. The square root of 9 over the square root of 2. It's easy for me to take the square root of 9. That just simplifies to 3. But I'm left with this radical symbol in the denominator. So to get rid of that, I'm going to multiply it times itself. And if I multiply the denominator times the square root of 2, I also have to multiply the numerator times the square root of 2. So I end up with 3 times the square root of 2 all over 2. I want to double check and see if I can reduce that fraction, and I can't, so I'm fully simplified on that problem. On the next problem, I'm going to start the same way, square root of 40 all over the square root of 48. I'm going to simplify each of the parts of that equation. So in the numerator, I've got 2 times the square root of 10. And in the denominator, I have 4 times the square root of 3. And if you need to pause for just a second to reassure yourself that I have done that work correctly, I've basically just taken those square roots and I've simplified them. Now I have a square root in the denominator and a square root in the numerator. I don't really care about the one in the numerator, but I've got to get rid of this one in the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 3, because that's the part that I need to get rid of that square root. So the square root of 3 times the square root of 3 is 3, but I also had that 4, so this is going to be 3 times 4 in my denominator. In the numerator, I have 2 times the square root of 30, so I'm going to multiply that 10 times that 3 together, and I get 30. I'm also going to ask myself at this point if that 30 can be simplified. So I know that 30's factors are 6 times 5, which is 2 times 3 times 5. So I can't simplify that any, but I always want to check for that, because sometimes when I multiply two numbers together that are under the radical symbol, I will end up with a radical that I can simplify. So at this point I have 2 times the square root of 30 all over 12, and this time I can reduce that fraction, so this is going to become the square root of 30 over 6. Now that we've done some problems together, why don't you try a couple of them on your own? Go ahead and pause the video, complete these 2 problems, and then unpause for the solutions. Now that you've finished those 2 problems, let's check your work. On the first one, I'm going to multiply by the square root of 21 in the denominator. I end up with just 21. I also multiply times the square root of 21 in the numerator, and while I'm doing this, I'm double checking to see if I have any perfect squares in here. So I'm thinking to myself that 10's factors are 2 times 5, and 21's factors are 3 times 7. None of those are in common, so I'm not going to have a pair of factors to take out of the house. So I just multiply those 2 numbers together and I get 210, square root of 210 over 21. On problem number 2, when I multiply both the numerator and the denominator by the square root of 7, I do notice that the factors for 21 are 3 times 7, and then I'm multiplying times 7, so that 7 times 7, the 7 can come out of the house. The other factor of 3 stays in the house. I have 7 in my denominator, and then at the end I can reduce those fractions. So hopefully you feel pretty comfortable with those problems at this point. I would consider that these are still the easy problems, and now we're ready to move on to the medium ones. All right, so the medium problems when we're rationalizing the denominator are expressions where I have 2 terms, but that I can find a common denominator. So when I have 2 terms like this, I'm always going to start by simplifying any term with radicals in it. So I know that the square root of 16 simplifies to 4. The square root of 15 doesn't simplify to anything. So I'm just going to leave that way. I know that I'm going to have to rationalize this. So I'm not even paying attention to the second term yet. because I look at it and I know that it's going to be pretty easy to deal with once I am ready to deal with it, but I want to rationalize this denominator first. So I'm going to multiply both the numerator and the denominator by the square root of 15. So I end up with 4 times the square root of 15 all over 15. I'm double checking if there's anything I can pull out of the radical symbol here, and there isn't. And I'm double checking to see if 4 and 15 reduce, which they don't. So I've fully simplified that first term. Now I have 2 terms, and I'm subtracting the second one from the first one. And I remember that when I am subtracting or adding, I have to have a common denominator. So I'm basically changing that 1/3 so that it has a common denominator. So I've multiplied the denominator by 5 to get to 15. So my numerator is also going to be multiplied times 5, so I have 5 over 15. Now that I have a common denominator, I know that I'm just going to add or subtract my numerators. So this problem actually simplifies to 4 times the square root of 15 minus 5 all over 15. And that might not seem really simplified to you, but I have made it into one expression with the same common denominator. My next problem is going to be pretty similar, where I have one term that I need to simplify, the other term that's already simplified, but you'll notice this one is a little bit more complicated because I have radicals in both terms. This one is already fully simplified, so I'm just going to ignore it for right now, and I'm going to focus on this term. So 2 times the square root, 2 divided by the square root of 12. I'm going to multiply both the numerator and the denominator by the square root of 12. So I end up with 2 times the square root of 12 all over 12. And you may have wondered at the beginning, if I had simplified this, if I had made this 2 times the square root of 3, I could have reduced my 2 and my 2 and had this be the square root of 3 times the square root of 3. That would have been fine. In these problems, because I'm dealing with multiplication and division, the commutative property applies, and it gives me a lot of flexibility about the order in which I do them. So I just picked this order, but keep in mind that it's very flexible. When I get to this point, I still have to simplify this. So the square root of 12 is, 12's factors are 4 times 3, so this is going to be 2 times 2, which is the square root of 4, times the square root of 3, all over 12. And then I can reduce this 4 over 12, so that term becomes 1 over the square root of 3, and I've got my square root of 3 up there. So all I've done so far is simplified this term. Now, I'm going to switch colors, and let's move this up a little bit. Now I'm going to go back to my original problem. I know that I've got the square root of 3, and now I've simplified this other part to the square root of 3 over 3. I know that I need a common denominator, so my common denominator is going to be 3. If I multiply the denominator by 3, I have to multiply the numerator by 3. So basically in this step I've just given them a common denominator. Now I have 3 times some number minus 1 times the same number. So in this case I have, this is almost like saying 3x minus 1x, because the square root of 3 and the square root of 3 are the same number. So I can do, and I'm just saying that it's x to think about it as a variable, because I know if I had given you 3x minus 1x, you would know that I could combine those like terms. So these are like terms because they have the same radical. So I've got 3 of them minus 1 of them. That's going to end up with 2 of the square roots of 3 all over 3. Again, I'm going to double check and see if I can do any reducing, and I can't, so I'm done with that problem. So now that we've done a couple of the medium ones, I'm going to give you a couple to try on your own. So here are 2 practice problems for you to do, and once you've completed them, go ahead and go to video number 2 for this lesson.